Well, I'm Dan Whitmore. I work for Cascade Built. I also do independent consulting. I'm also on the FIAS board. I'm on the Passive House Northwest board. Passive Obsessive. I've been doing this for 14 years now. I'm the project manager and site super on this project. I'm also the janitor on the project and custodian. I'm also the client, and I'm on the CPHC as well.
I'm Skylar, and I've worked with Dan for a long time. What's this? How many units?
So 12 units, about 10,000 square feet, 9,400 ICFA and whatnot. It's called the Red Willow Apartments or Red Willow Project. It is a project of the Red Door Sustainable Housing Group. That's myself and two other colleagues, and we're endeavoring to provide sustainable, stable housing. The equity investors are taking a limited return and funneling what would be the market rate, the standard market rate return, funneling it into reduced rents, stable rents, and a better building.
So how do you think the passive house element kind of tied in with those objectives?
You know, everyone's like, well, of course, we're going to long-term hold, long-term care for the residents. It's just what should be done. I didn't have to sell it to myself, and the colleagues who I was working with were like, well, sure, of course, if that's what needs to happen, that's what needs to happen.
So I'm just looking at this project, but it looks pretty conventional from the outside, Dan.
Yeah. Floor to envelope ratio is really good. We've got 12 units, 12 kitchens, 14 bathrooms, 21 bedrooms. So the internal heat gains are really pretty good. We're in very much a heating dominated climate, so we didn't have to work very hard. So 2x8 wall, marginally advanced framed. We endeavored to keep the wood out of the wall, to keep the insulation in the wall, but it's still 16 on center. The drywallers like it better, the siders like it better. So that's it.
No doubt. I found that on my projects as well. Yeah. It's usually easier just to do 16 on center and keep things typical and normal. One thing that I'm seeing is you have your rain screen on, and over your fully adhered air barrier. It doesn't look like you're going to have any continuous insulation. So let's talk about that a little bit, because usually you see passive houses and you assume they're going to be wrapped in thick layer of foam or mineral wool or a Larson truss.
Mm-hmm. There was an option. Okay, do we put exterior insulation, or do we use a better window? Like, we could have used a slightly lower performing window and put exterior insulation on, but for me that was a no-brainer. It's a slightly loud location. Got a good supplier, Euroline Windows out of British Columbia, bringing in the windows next week. And with that, a 2x8 wall filled with fluffy stuff, you know. Yes, I would have loved to use cellulose, but we're in a market here where cellulose is premium, and the crews aren't familiar with it, and so I want it to be perfect, so I want to use what they like to use, so we're using fiberglass.
Yeah, I think it's super important to use what your trades are comfortable with, and I think that's how you end up making projects like this happen, because your shell is going to be super airtight. The insulation is going to perform like it says it will on the label, and I think it's really cool that you've avoided that whole extra step of adding additional labor and upfront emissions to add continuous insulation by instead just using wood framing and not having any steel that you need to have continuous insulation over. And then to crank the airtightness knob and make the building super airtight, because you're performing better than a code building that doesn't have as stringent airtightness levels. What's pretty cool is you're actually going to have way less heat loss than a building like that without as high of insulation values. That's a lot of material that you're not having to put on the building now just because you had faith in your airtightness layer. Since airtightness is a critical part of the performance of this project, and by cranking your airtightness knob, it's allowing you to effectively not have continuous insulation in combination with your high performance windows. Can you tell me kind of your sequencing and your detailing and what you're doing to connect all your dots? And let's just start with your wall to foundation interface, because this is a critical one.
So I'm a big fan of simplifying sequences as much as we can. Foundations in concrete is always one of the toughest ones on pretty much all my jobs have been that way. So to integrate insulation and air barrier in the foundation sequence is pretty tough. So simplify. So this project also had some bad soils underfoot. So we had a lot of excavation to do. So it doesn't look like it because it's flat, but this wall goes down 4 feet. So cast concrete, we minimize it to just a 6-inch wall. Engineer worked with us on that to minimize our concrete content. as long as it's done well, it does a great air barrier. So
Totally.
okay, our cast stem wall, that's part of our air barrier. Now we need to transition to our wall. Could have used the sheathing itself to do the air barrier, but because we were building in the middle of winter, we just chose to use self-adhered membrane. So this system has a tape that will bond well to concrete and to the
that
sheathing.
stuff stuck on there. Awesome.
That
I love
stuff.
that product really oozes into the concrete pores and sticks
And
to
that
the sheeting.
that right there has been on with full solar exposure for 2.5 months. Even after 2.5 months, it's not moving. It's great.
You're not having to connect your continuous exterior insulation. You don't have foam under your footing or foam that you need to protect on the outside. And all of us know that have run foam on the outside of the building, that protecting that long term is always a pain, whether it's with metal or stucco or whatever. It never looks awesome unless you spend a lot of money and time on it.
Yeah.
And so it's really sweet that you're going to have your exposed concrete foundation there.
Yeah.
And so that's just all those little things add up on your project to make it penciled, make it buildable.
Yep. We know we need to maintain some things, but anything we can do to adjust our details so we can make maintenance simpler long term.
Any tips and tricks when you were applying this? I see a lot of projects all around Seattle, Boise, wherever, and they have this fully adhered membrane and it has wrinkles in it.
Yeah.
And this looks great. I've nary a wrinkle on this job site.
The guys putting it up are doing fantastic. And when we brought out the product rep, he gave a quick coaching session, and they've just been paying attention to it and detailing it right. So big shout out to the siding.
It looks like you've got some areas where you have some interruptions in your air barrier. You obviously worked with your structural engineer, so it's not continuous structural members going through the air barrier, which is the sheathing layer. And so was that a big deal to just attach this to the outside of the building?
All it took was, okay, framers, hold off, give me 2 hours on a not rainy day. We were framing in the middle of the rain, so I needed to sequence in a dry day, a day when I could get in here and put air sealing components on the sheathing that would be covered.
Yeah, it looks like you did some fluid applied flashing membrane behind that before they framed it and attached it to the structure.
Exactly. And just for good measure, I was able to get up there and install this tape over the straps as well. So fluid applied at my joints because it was really wet, and then it was a little bit drier right the next day, so we just covered those over. You want your crews to be working as fast as possible. You don't want to get in their way. But we want to just say, hey guys, let me just do this before you, it's going to take, they're not going to frame this roof before they frame the upper wall anyway. So just making sure I've got in the right spot.
So we're at a transition where the foundation to wall air barrier is transitioning into a door buck or into a door opening. And there's a lot of things happening here, Dan. So we have to interface with thermal bridge free detailing with insulation on the foundation wall, but then also all our air barrier transitions. So can you kind of put all this together for us?
Absolutely. So air barrier is 6 inches of concrete. Oh, but below it, it's 10 mil of poly. So this is the poly.
So this is the sub slab vapor barrier that's on top of the rigid foam that you installed under the slab,
which is also my air barrier. So it's my vapor barrier and air barrier, and it's detailed throughout everywhere. It's actually, you can see right in the corner, it's taped. So the 10 mil poly is taped to the concrete wall with this tape that, again, similarly bonds well to concrete here, bonds to wood, bonds to poly also. So it's still in process in that we need to come around here and we're going to make this air barrier transition come up over this door saddle. So
this will be what your door bears on?
Correct.
Perfect.
And then right below it is a 2x4 on edge that's ripped to the imperfect sill opening. So our air barrier, we don't want it to go underneath it. The air barrier here needs to connect to the window air barrier. So it's actually going to get taped up and over to the top. Then our window will be, our door here, our patio door will be sealed at the back edge. Now over here, again, where the tape is going to make the same transition from poly to concrete, from wood to concrete. And then we're going to come up here and the same tape that made the concrete to wood connection is going to make the concrete to wood connection here. This is going to get a wrapped outside corner. All the windows and patio doors here are actually flange mounted. So they're going to be wrapping around the corner here, and then so our air barrier will be sealed at the back edge of the patio doors and windows in here. So our air barrier comes across this blue membrane, transitions to a tape that wraps the corner, then transitions with the sealant to the patio door itself. So lots going on as three-dimensional consideration. Normal framed walls would be a 2x6, but since we've got a 2x8, we're actually, and the sheathing is flushing out with the outside face of the foundation, we're actually able to get a good 2-inch, inch and 3/4 to 2 1/4, depending upon how well the concrete
Yeah,
did.
I love this detail. Scott is always good about doing that, and I think other carpenters like doing. I know Scott Gunter always liked to keep it flush, and I found that myself when I'm doing this air barrier detail, it's nice not having the bottom edge of that plywood or zip sheathing or OSB to contour around.
Yep. And it gives you an extra 1/2 inch of insulation.
By doing this foam on the inside, it's allowing this detail to avoid having foam that goes all the way down the face of the stem wall, around the footing, under the footing, which would be a load bearing and a whole nother sequencing event, and then up the exterior foundation wall. Then it would need protected, and then you'd have to deal with that transition to the above grade. So all these little details add up, and it's amazing if you do a thicker stud wall and you cantilever it out over the foundation wall, you can get all you need even for a passive house project.
The wood structure is only 5.5 inches deep. So you tell that to your structural engineer, then they say, oh yeah, no problem to have your full depth stud only be in certain locations. Right here, we're actually stepping back to a 6x6 that's carrying my hold down. So I've actually still got another 1 3/4 inch insulation even over my main structural members.
On the face of your structural members, which are already fairly low conductivity wood.
Yeah.
And so it's becoming pretty evident why when you, especially on a multifamily project, when you frame with wood and you get the details right and you get the air tightness right and you do good windows, you can in some cases avoid any continuous insulation. That's really cool. Let's talk about the underslab, air and vapor control. This whole slab is insulated with reclaimed EPS foam, which is awesome that you have the patience to do that.
And yeah, it actually wasn't, it was a small amount of more work to just cull through the bad pieces.
Okay.
I'd also like to the same colleague he's a little bit of a foam recycling or reuse fanatic. So all of the blue foam you see around the building was also reclaimed. The only foam, this whole building, which is all on foam, the only foam is the structural foam, and this is a leftover piece of it that is under the structural locations. I needed to get that because I needed the stamp and all those sorts. So that's type 29 structural, higher density foam.
If you had just maybe allowed your footings to be uninsulated and had those thermal bridge, just took that hit in your energy model, it might have meant you needing exterior insulation, for example. And so it's all these little kind of tricks and tweaks and nips and tucks that allow kind of the overall performance of the project to happen. It's still a really good value in terms of like extra pieces added. We're
actually going to get an extra piece of foam right here, so we're going to have a thermal break at our door jambs as well, and so we're spending that little tiny bit of detail on these little unique conditions. Under our structural, this thickened portion of the slab, that has 1.5 inches of foam. What was a unique sequencing component on this project where for plumbing permitting reasons, we actually were held up on placing the slab so we couldn't get our plumbing groundwork in a timely fashion. So we went ahead and framed the building up bearing on some interior footing lines. So these existing interior structural walls that are carrying the building above are on the same type of foam, but so those areas it actually are in a small moat of foam.
Perfect.
And so, but we're coming across and we're joining up with them.
So Dan, do you think we can pop this off and maybe see how you interface to your
Sure.
foundation wall, which is your kind of serving as your air barrier transition from the inside to the outside?
Absolutely. So the team did such a good job. It's all just friction fit around the perimeter. There's always a concern about concrete getting underneath, but they did. We were just like, make sure it's tight. Got the right tools, got a nice cutting table, and so it was easy for them to do without too much mess.
So again, we're on foam. How thick is the underslab foam?
5.5 inches here,
5.5
R20.
inches. Okay.
1.5 inches here.
Under the structural footings.
And that gives us a 4-inch difference. So we've got 4 inches of concrete for our slab, 8 inches of concrete for our structural locations. So it's a consistent flat, roughly 1 inch of sand above capillary break fill.
Awesome. So yeah, let's pop this off. And this is also going to show you this top plate as well. So I think it'll give a nice visualization of this overhang too.
Yeah, so this is a 2.25 inch. This is an R10 high density structural foam.
Yeah, that's some awesome air barrier detailing you got here, Dan. So you've got your sub-slab air vapor control layer, and you've got this awesome bomber tape that is really stuck onto that foundation wall.
The one weak point, of course, is the transition here, and so we just made sure we hit it with some sealant, so it would that bonds well to both of those components. So that little corner, with a little bit of sealant, did it. Could have put another piece of tape over it, but they did a good enough job with the tape. Things aren't really moving. There's no. It's holding stiff. Were there to be any flexion or compression in the tape, the membrane, or the foam, you'd want a little bit more of a reinforced corner, but we don't need it. It's creases and wrinkles in it, and so you see all this sealant.
Yeah, so it looks like there's some like little fish mouths and areas that you had to slather.
Scattered everywhere.
Yeah, that's a pain.
Partially because it came off the roll with this mess, in addition to the difficulty of getting in place. It's also really rough with all the plumbing coming up through. We just cut a rough hole in the main primary layer, and then essentially gasketed around it with a 16 by 16 piece that could be cut tight to the circle. And then there's a tape that does a nice job of sticking to the plastic and sticking to the pipe, kind of bending around, finally reinforced with just a layer of sealant as well.
I guess there was an advantage of holding off on pouring the slab, because at least you weren't having to apply this membrane in the wet, because that becomes a nightmare trying to wipe things down.
Yeah, it's kind of, I would say it's almost impossible to get a good air barrier when it's raining. The problem with Seattle rains is also it's not a half hour here and a half hour there. It literally is 10 hours of drizzle. So you can't. It's just the nature of our winters. So
in retrospect, it's brilliant to, build without the slab.
The plumbers were pretty happy.
So Dan, what's going on with these header details? I'm not actually familiar with it. Maybe it's just because of the 2x8 situation, and then the post being thinner. What can you explain what's going on here, and does it have anything to do with thermal performance, or was it all structural?
No. Well, it's a combination of those two. Combination of, okay, this is what we need for structure. How can we optimize for thermal and optimize how much wood we're putting into our building? However many years, 50 years ago, we went from a 2x4 to a 2x6 in this type of construction for insulation purposes. We're now commonly shifting to a 2x8. It's actually quite common in Seattle to do just your standard building out of 2x8, purely because they want a higher R value in the wall. So, but our structure doesn't need to be, so 2x8 is 7.25 inches deep. Our structure doesn't need to be 7.25 inches deep. In fact, our headers only need to be 3 inches deep. So what we're doing here is, this is a 6x8. It's connected to a really big structural hold down for our seismic concerns. Well, that's bearing on that 6-inch concrete stem wall. Well, the only thing we actually need in these walls to go from outside of sheathing to inside of wall finish is the perimeter of the window. So our drywall stops here. So we're capturing our drywall. We now get insulation in front of this structural post, but the same thing in front of the header. Now I get, what is that? 4.25 inches of insulation in front of the header. It's just a doubled 2x.
Mm-hmm. And so the only reason that's necessarily extending out is really just for backing for your drywall to attach to at the top of the header there.
Yep. And then the cripples on top, they're just, they're there just to capture the drywall. I don't use dimensional number as any part of my air barrier anyway. So our air barrier will be transitioning across the interior face of those the tape will be coming into the roof opening.
All right, Dan, you walked us through your underslab air barrier, your foundation to wall interface, your wall to cantilever floor interface, and we're just moving up. Our air barrier is going up your wall sheathing again. And I would just assume on a lot of projects that have unvented roof assemblies, we just wrap right over and use the roof deck as the air barrier, the structure of the roof deck, whether it's plywood sheathing or whatever it is. But you have a vented roof assembly, so you definitely are gonna have another step with your air barrier here, but
Yep.
it has some advantages for sure.
Yep. So we are transitioning from our wall, and on our wall, it's the membrane with the substrate of the plywood. So now we need to transition to the underside of our ceiling, which, well, it's actually not the true underside of most of our ceiling. We actually have a slightly convoluted transition
You've got
point.
You got your air control layer, your thermal control layer, your vapor control layer, and in this case now you got your fire control layer,
I
right?
got my fire control layer. Another problem I have is I have my height limit on my building. So the zoning code here says defines your height limit by top of wall, the top plate of the wall. And a raised heel truss pushes up into that. So I actually needed to essentially maximize my wall. My wall height is to my height limit, and I couldn't do this raised heel truss like that I wanted to do because I was up against my height limit. So we have a somewhat shallow heel. It's still R40 at the heel, but we're transitioning up from that, going vertical. So we can take a look at it if you'd like to from the inside.
Perfect. In the inside now, on the top floor, and Dan's gonna walk us through how the air barrier is transitioning from the exterior wall sheathing to the interior air barrier that's gonna be at the ceiling layer. And I guess, what's that air barrier gonna be made out of? How are you going from wood to membrane to drywall?
The floor transition, floor to wall and wall to ceiling or wall to roof, those are definitely the most awkward ones. And this one's a little bit awkward also because we have that height limit, and I don't have any really allowable additional soffit area that I could just to fill up with my mechanicals. So my air barrier needs to accommodate the sprinkler systems, the lighting systems, a
all
little bit
below
of the
your
plumbing
air
systems.
barrier.
All my ventilation systems are all below my air barrier, but I've got this height limit, and so they measure their height limit to right there. Okay, so I couldn't go any higher than that, but I need space to put all those mechanical components. So I'm actually jumping at the first truss up. So my air barrier on the outside, remember, is the membrane on the outside.
That's on your structural sheathing. It's wrapping across.
This membrane is sealed to the outside sheathing, the back face of the sheathing.
With tape.
With tape or sealant. Some days
Okay.
it was too wet, so we chose between based upon the weather that day. So that blue membrane is adhered to the sheathing layer. The sheathing layer comes past the top plate, 3/4 of an
So it
inch.
has to wrap and contour down that.
Yeah, and then
Okay.
it goes across this. So this is my air barrier now. There's no penetrations on the top that are not, well, there's nails down through the top, but they're
Yeah.
self-sealing. So now I get to bond to this. So we went from the light blue self-adhered membrane to the structural sheathing, and then the structural sheathing, we made a transition to this dark blue membrane with a sealant and tape.
And that's going to then transition to your interior ceiling air barrier. What were some of the trickiest parts executing this? I see, oftentimes when I see the exterior to interior approach, the interior walls seem to be an issue, especially when they're a load-bearing wall.
Yeah.
Getting a sequence where that still continues, and then making sure this membrane, I'm sure you had to have another step where you taped the joints, like basically where you had strips.
Yep.
Then you'd have to tape those joints and then
Yep.
run it across. So
Yep.
was there any other tricky, weird details?
Well, one of the
you can
tricky
point
weird
out?
one of the awkward things is, the framers, they just want they want to do their job and get an air barrier in the way. So in order to protect this from damage by subsequent trades, we put this 1/2-inch rip of plywood on top. So basically, this is a No, this is a protection layer of plywood that's then going to plane out with my ceiling.
Yeah,
drywall.
when I first saw this detail, I was a bit confused because I thought you were using that as your air barrier, because that's a classic detail in the passive house world, was where you run your exterior sheathing, run just a sacrificial strip of exterior sheathing on the inside that then you can connect to. But in this case, you just use it as a spacer and you have the membrane underneath it.
And your comment of like the butt joints and all this, one of the reasons we did that is because I could do a 50-foot strip of membrane. There's no butt joints.
Yeah, versus when you do it with sheets of 4x8 plywood, if you're walking and framing, you have goop there, or it's too wet. It's a flat surface and water pools on it as well, so that can be problematic for sure.
And we were framing in January, so it was it was wet.
Okay.
So that was a protect. So that combination. And you're absolutely right. We now also have these walls, so I had to bring this membrane over. So these were the complicated components. What happens when we have an intervening wall coming through? So you'll notice it stops right here though, because my air barrier is going to come across to this first truss plane and then jump up and go across below. So I'm creating a really shallow ceiling.
So this is really going to be your service cavity in this space, and your air barrier is going to be above that.
Yep.
And really, that membrane is going to have to then connect to your drywall, your 2 layers of fire rock. Okay.
Yep. Yeah. So I am gonna use the double layer of Typex drywall. That's on the bottom side of here. I'm going to use that as my air barrier. So there's going to be, the toughest thing is, what Skylar and I were talking about earlier, is making the transition from this dark blue membrane to my fire rock layer.
Yeah, and in the passive house world, we kind of shy away from using the drywall as the air barrier.
Yeah.
Airtight drywall is generally not airtight, and especially when it has a lot of penetrations. But what's cool about this detail is because you've done the steps with the spacers and the transition membranes, you can create a continuous air barrier with that drywall. Yeah. And so it's possible. It takes detailing. If it was just a standard project and they were relying on that ceiling drywall as the air barrier, it wouldn't really pass muster. But with it being continuous and having the spacers in place, I think it's going to work really well.
I'm going to have to protect it. I know that. I'm going to have to do a lot of work to keep people from damaging that layer above.
But you really have minimal, like what penetrations are going to go through that to the attic? Instead of a situation where you have recessed can lights and fire sprinklers and all these other penetrations, you really are going to have maybe some ducts that go to the outside and maybe a couple of electrical wires that have to run to maybe outdoor fixtures or something.
My sprinklers, I'm mostly worried about the HVAC systems up there, but it's just ventilation
But
up
it's
there.
really not going to be going up to the attic, except in those, So
we
really,
tried-
in this case, it's serving multiple functions, which is awesome when you needed that layer anyways. So for the bulk of the cost of that air barrier or that air control layer, it was going to need to be there for fire control anyways. And so your extra cost is just the integration and the detailing. Other options you could have done would be a full membrane under here, which would have been a whole nother step. And then also, I think maybe talked about doing plywood or OSB and taping it. But again, if you're going to be able to do OSB in a continuous manner, you should be able to do the drywall in a continuous manner. So it should work out.
Yep. And this whole, we're going to sequester a lot of carbon because there's no sprinklers in my attic, which means I have to fill the whole thing up with insulation. So got a major carbon sink going in this roof here. So,
Awesome.
So, no foam. Actually, it's not true.
There's some unvented sections.
There's a few minor unvented sections because of the valleys running along.
And I think this is a perfect example of there's certain construction details where you got to use the best tools in your quiver, and you're using it where it makes sense, and you're going with fluffy insulation when it makes sense, and it's just working with what you've got. So tell me how you bridged all the way from your exterior wall sheathing to these interior partition walls, because it looks like you have some beams that would get in the way of the continuity of your air barrier. Kind of like, what are these little details that people need to keep in mind? It's easy when you're drawing your plan and coming up with it to say, oh, this is how you transition on the outside, but it's really the pieces that you don't think about that matter.
So we've got 3 gables, which the design team liked and the design review board liked, but we then have 2 valleys. So now we've got two valleys that run the width of the building. Well, it's a good bearing plane, so it works with us structurally. Add it all up, what it really did complicate though is how the heck are we going to detail these valleys? Well, up above it's a low slope cricket, and then below it is an unvented roof assembly. So we have an unvented roof assembly for the width of the cricket plus a little bit. So it's about 5 feet either side of this central valley. And it's going to be an unvented application. We're going to put in the appropriate amount of spray foam. It's 4+ inches of high density closed cell foam. Washington mandates the HFO foam, so didn't even have to ask for that. It's just what we use. And then the rest of this void is going to be filled up with cellulose. So that's going to be our insulation strategy and our unvented strategy. We do transition right beyond it into an invented application. So there's an inline vent in our roof system here. The question about the air barrier is, well, at the perimeter we see over there, where on our walls, where we're coming across from the outside face, we're making a transition with the blue membrane across the top of the plate. We're making the transition to the drywall. This is a ceiling plane. That drywall is going to come all the way across the underside of the trusses. It's going to bump down. It's going to run across, and then bump back up for our service cavity on this side. So we've got our service cavity in each one of these 3 volumes. This one area here, we're going to have to install and protect our air barrier just to at the drywall plane. So it did mandate that when we were framing this roof, we needed to bring our air barrier in at all these locations. And unfortunately, we missed it here. We didn't get it quite deep enough at these walls. But so we're all set here now. We're almost done with all our mechanical systems in our attic. We'll be able to install our ceiling, our fire-rated ceiling, and then we can detail our air barrier from this point to this point. It'll then bump up to the bottom side of the truss cord.
Into your mechanical cavity, yeah. Great. All the money that you're putting in to invest in making your building more airtight is also going into making the building more durable, not only from an air leakage perspective, but even more importantly, from the water control layer. So all this additional resources and effort and detailing that you're putting in to making the building more airtight are also making it more resilient and less prone to damage from water intrusion. So it seems like a win-win as a developer and the project owner long term. Like, these things kind of make sense.
Yep. Every region is going to come up with their own, they're going to have their own challenges. I've got a great opportunity here because the trades know how to detail a building well for water. We've been testing our buildings for air leakage for a decade now, and so people know what it is. So some people in other areas aren't going to have that strength, but they're going to have the radon teams. Nobody here has to nobody deals with radon around here, so nobody knows that. So we're all going to have our areas where we need our sort of specialty team to get that aggregate. But just as you said, like the industry knows that it's in the instructions, it's best practice, following our best practice from these various considerations. It's fun, it's great. And
yeah, from a developer's perspective, with Passive House, you're getting what you're paying for.
Yeah.
Like, if you're going to be installing insulation, you're going to make sure that you're going to get the full R value out of that insulation.
Yep.
You know that it's going to work whether it's windy or not, whether it's cold or hot, it's going to work. And so that's really, I feel like you're pushing your building to perform to the best of its ability, which is really awesome.